Right. So today we are going to start from where we left last week, and we are going to continue discussing, the artificial intelligence and machine learning from a business perspective. Today the topics will be as follows. We are going to discuss a few common tools in the data science spectrum. We will discuss some techniques as well of artificial intelligence, and then we will see that which ML techniques, which language technique is applicable in certain scenarios, and why it is applicable in those scenarios. We will discuss that how artificial intelligence is used in forecasting, in making forecasts based on the historical data, how decision trees are used, how AI is used in retails for creating for making purchase recommendations, how chatbots work, and how the smart traffic light system works, and what are the convolution neural networks, and how do they help in in the smart traffic light systems. So this is how this is the these are the topics that we will be covering today. So now let's go straight into the stuff that we are going to discuss. So this is the spectrum of the data science that we discussed, I think, in the last lecture, where we said that from business value perspective, reporting and data analysis is on the lower end of the spectrum, and then it goes, and then the business value and the complexity as well, they start getting increased in the dashboard and business intelligence, and then predictive analysis, predictive modeling, and then machine learning, and then all the way up to artificial intelligence. It just, the complexity and the business value, all that just keeps increasing. So therefore, we need to see that, okay, what are the tools which are used for each and every, part of the spectrum? What are the most common tools? We did have a view of some tools in the last lecture as well, but that was from a different perspective. But let's see that from the perspective of a data science spectrum, which tools are most applicable. So in the reporting and business analysis and business intelligence, we have these tools called QLink, called Excel. It offers a diverse range of options, including pivot tables and charts, and let you do the analysis super quickly. And we all know, the benefits of Excel. We have used it in our daily life, etc. Now, the next one is QLink Q, QLIKQ. So this is this lets you consolidate, search, visualize, and analyze all your data sources in just a few clicks. Easy and intuitive to learn. It's a very basic and user-friendly tool as well. Then we have something called Tableau, Tableau. So it's one of the most popular data visualization tool in the market at the moment. It is capable of handling large amounts of data, and it offers something like Excel-like calculations, functions, and parameters. And it is popular for its neat dashboards of stories, of user stories and interfaces. And it also inculcates multiple reports on a single screen. Then we have something called MicroStrategy. So MicroStrategy is another business intelligence tool that supports the dashboard, scorecards, alerts, and automated report distributions as well. And then within the same spectrum, within the same business intelligence area, we have Power BI. It's an offering by Microsoft in the business intelligence space. It is built to integrate Microsoft technologies. If your organization is a SharePoint or they have a SharePoint or SQL database, then Power BI I think is will be quite a useful tool, and you are going to make more use of it because of having those SharePoint and SQL database. It does connect with the non-Microsoft softwares as well, though. So yeah, and then you have something called Google Analytics. Now, Google Analytics is a digital marketing tool and is playing a major role in transforming your businesses. And at the moment, they say that there's no better tool in market than Google Analytics, and yeah, so that's all about it with regards to business intelligence. Now let's move on to the predictive modeling and machine learning tools. So we have merged these two, predictive modeling and machine learning, into one because the tools are the same for both part of this spectrum. So this is where the bread and butter of the next of the most data science professionals come from. There may be an overlap of tools in these two domains, but this is because tasks tend to be similar in nature for both of them. So number one we have is Python. Number one, not in the in ranking or anything like that. It's just number one. So Python, it's the most dominant language in the industry. It is flexible and it is easy to use. It is open source in nature, and it has gained quite rapid popularity and acceptance in the machine learning community. For organizations just about to start their journey in AI and ML, it is highly recommended to start their journey with Python as a primary language. Then you have something called R programming language. It is also a very popular language, and at one point it was ahead of Python. So this is an incredibly useful and supportive community. There is an incredibly useful and supportive community associated with R language. It comes with plethora of packages and libraries that support most machine learning tools. Then you have something called Spark. Spark is again a tool presented by Apache. It is also open sourced. It is actually open sourced by UC Berkeley in 2010, and it also has one of the largest open source communities in the big data space. So I mean, some people call it as a Swiss knife of big data analytics because of its multiple advantages, including flexibility and speed, among many other things. Then we have something called Julia computing. It is an upcoming language being perceived as a successor of Python. It may be too early to make that judgment, though, whether it's going to be able to be a successor for Python or not. But yeah, that's the claim some of the people are making. Then we have something called Jupyter Notebook. It is mostly used for coding in Python, while they do support the other languages too. Python is still the favorite among the data scientists. So these notebooks are used by data teams in companies like Netflix and Facebooks and Ubers and others. All the tools uh, on these slides so far that we have discussed, they are all open source tools. So you don't pay for them or purchase any extra licenses for them. They and they maintain and they release the updates quite regularly. So now have a look at some non-open source tools. Um, these are the tools for which you may have to pay for the licenses and some fees as well. So the first one among them is SAS. It is a very powerful tool. It is used in banking and financial sector globally. Easy to pick up for those who have experience on SQL. Uh, it has its own certifications, which is not easy to get, and it has a is a quite a high market share in the private organizations like American Express and JP Morgan and Royal Bank of Scotland, etc. Then we have something called SPSS from IBM. It is called Statistical Package for Social Sciences. Now, it is acquired by IBM in 2019. It offers advanced statistical analysis and a vast library of machine learning algorithms, text analysis, um, and yeah. And then last but not the least in this space is called MATLAB. It is not widely adapted on the organizations level though. It is mostly popular in academia and research divisions. And then finally, in the artificial intelligence space, we have uh, tools like uh, Google Cloud Platform and IBM Watson and and data robots. So I mean, these are the tools which are going to be the big thing in the artificial intelligence space. And with this, we will move on to our next part, which is we are going to discuss about the common techniques that are going that are used in the supervised learning and unsupervised learning and reinforcement learning. Now the thing is, I mean, this is the slide that you must have seen in the first lecture 2 weeks ago. So we are just going to dive a bit uh, more into detail of these slides and see the content of this slide and see that at what stage and what are the factors which make us choose to either opt for the supervised learning, unsupervised learning, or reinforcement learning. So as a business leader, because it's quite important to appreciate the distinctions, so we know what challenges are our team going to be facing while using these one of those techniques. So in order to explain that, let's have a look at this chart, or it looks more like a decision tree. So let's have a look let's have a look at it. And the first question that we need to ask ourselves that do we have a target variable or not? So what is a target variable? We need to understand that first. So target variable is this is a response. Target variable is a response uh, or a dependent variable in the simple terms. I mean, it is like an output to your ML process. we need to understand that if you have a target variable, then actually you are solving a supervised learning problem. But if you don't have a target variable, you don't have a response in mind, you don't have a clear-cut target to achieve in mind, then you are dealing with an unsupervised learning problem. We will discuss that a bit more in detail, but let's you know take this in mind that if there is a target variable which is uh, uh, which is a certain response, then it is going to be a supervised learning problem. But if there is no target variable, then it's going to be an unsupervised learning problem. Uh, if the target variable is especially if the target variable that you already have, it is continuous in nature, then you will be solving a problem via regression. But if the target variable is uh, not continuous, it is fixed, then you are solving the problem with the classification. Uh, so we will, just don't worry if you don't understand these terms. I'm going to explain them with the help of examples very soon. So, but let's go through this tree for now. And in the supervised and in the unsupervised learning atmosphere, where you don't have a target variable, that is, you don't have a particular response associated, then you are solving the problem uh, with uh, with with clustering. Now, so let's see. Uh, just bear with me for a moment. And the next one is what we have called reinforcement model. So we just saw that we have supervised learning, unsupervised learning, and now we have reinforcement model. Reinforcement model is the third type of learning, and I mean it is just like uh, uh, I mean we can compare it uh, the way child learns to to walk. Maybe a 2 years child, when he learns to walk, it is like uh, they attempt to stand up, and they try to balance themselves, and when they try to balance themselves, they decide to take the foot forward, they decide to take their first step and walk forward. So you can say that in this example, you can compare the child with an artificial intelligence agent. The child takes an action on the surface like a floor, and if they are successful, uh, then uh, they start walking. They get cheerful and they start walking, and if they're not successful, they fall down and they get upset. So this is the feedback cycle which carries on throughout the process. And uh, the reinforcement model in the machine learning is similar as well, where the agent takes an action, and if the action is successful, it rewards itself, and then based on that reward, it again um, takes the action, and so on and so forth. So now let's have a look at at uh, at these examples a bit more in detail, the ones that we have just discussed. So we are saying that that regression is a part of your regression is something that is applied when you are taking the path of supervised learning, and especially when your target variable is continuous. So regressions are all about estimating the future value of your of the continuous value, of the continuous variable. We just said that when you have a continuous variable, the answer is yes. Then you use the regression process. So, and regression problems are all about estimating the future value of your continuous variable, like predicting the price of a house. So how you predict the house of your of a house. For example, if you want uh, uh, to uh, to purchase a house, you provide a bunch of variables such as the size of the house. You say that whether it's going to be a 3-bedroom house or a 4-bedroom house, and then you provide the postcode of the area, and then you say that um whether the house is going to be detached or semi-detached or terraced. So all these parameters are going to go in, and based on that, the algorithm on a website like rightmove.com or zoopla.com, they are going to predict the value of the house, whether it's going to be 500,000 or 600,000 pounds worth of a house. They are going to predict that. So that has happened by using uh, the regression method, in which your target variable is continuous. Um, there is also a usage of this regression methodology in the marketing area as well, where, for example, a company is just about to launch a new car into the market. For example, perhaps BMW is going to be releasing their new model into the market. So this helps them deciding what should be their their launch price of that particular car, and this is all based upon um, the regression method, because of the fact that their target variable is continuous. Now, let's look at the classification. So it's all about predicting the probability of of a certain event, whether it's going to happen or not happen. For instance, classifying your emails in your mailbox into the spam or non-spam folder so this is an intuitive way of a classification problem. Trying to understand whether uh, a credit card fraud is going to happen or not, or somebody is going to breach their credit limit or not, or somebody is going to miss uh, their um, their a monthly payment of their loan or not. So these are all classification problem. You have something like a binary situation, 0 or 1, yes or no, these kind of things. So because of that, you say that it's a classification problem. You're going to classify that whether or not somebody is going to to uh, to claim a fraud, or your email that arrives in your mailbox, whether it's a spam email or not. So this is um, okay. So now let's talk about the clustering. So, clustering is also called segmentation. Uh, this is where you decide the population into this is where you divide the population into subsets based upon certain predefined criteria. For example, dividing a group of people into 3 different sets based upon their demographics, like their location, their total work experience, and a commonly uh, so uh, So yeah, I mean that's how you say that. Okay, you have maybe 10,000 people, and how you are going to differentiate between them. Um for a restaurant business, for example, when they are trying to um, make boundaries to decide which geographical sector a certain delivery person is going to operate in, clustering is quite a useful tool for them. So that when an order is placed from a certain location, their algorithm will decide by itself to locate a delivery person in that area, and then they're going to uh, just send that person to serve that area. This is also used quite a lot in the taxi businesses, especially in the uh, uh, Uber app, where with the help of clustering, the system is going to pick the taxi drivers in that area, and then the person has a choice to pick that taxi driver and and uh, and and make use of that service. Um, okay, so let's look at it a bit more in detail. So we are going to have a detailed look into how forecasting is used based on the historical data for the businesses, and how regression uh, modeling is used uh, to is helpful in that. So I mean, if you look at the screen, what you have is that you have a sales data of an organization on month by month basis from December 2000 from December 2018 until December 2020. You have 2 years of sales data, and you can see that there's a pattern which is being followed every quarter. And you can see that at one point the sales data is quite low in that quarter, and then it just start going up and up, and then it falls down, and then again it starts going up and then it falls down. But there's a linear progression as well that you can see. So until 2020 you have this data, but in 2020 you want to predict the future. You want to see that, okay, what's going to happen in the next quarter, which is January 21, February 21, and March 21. And this is actually the crucial thing for most of the businesses, because they all want to see uh, the future. They want to understand that um, what would be the future holding for them, and based on that they want to create their strategies, and they want to plan their to plan their business ventures. So so this is the problem, and we have to see that what techniques are there for making such a forecast. So one of them is called linear regression. Uh, Linear regression is is the one which is going to give us a continuous output. Uh, so it's quite simple, that they just said that, okay, there is a very simple trend of sales getting increased um, every quarter, and they just very simply, from December 2020 onwards, they just took the line straight in the same direction, and they said that, okay, so based on the data that we had so far, um, the line is pretty simple, and we are just going to follow the same pattern which we were following in the previous quarters, and based on that the data is going to look like that in your next quarter. I mean, as shown on the screen at the moment, after this black vertical line. Um, so linear regressions gives a straight line, but while this approach is quite easy enough to implement, it does not provide the most accurate result as well, because the sales of a product never follows a straight path anyway. There could be further ups and downs. For the sake of this example, we have kept it quite simple, but in the real sense, it could be, these ups and downs could be very uh, different in the real life. So that's why they say that it is not the most accurate way of predicting the future. So so that's why there is another technique which is more advanced and a bit more applicable, which we call as moving average. So how does a moving average work? Um, if you can see on this table, we have the months, we have sales, and then we need to make predictions from October 2020 until February 21. Uh, we do have uh, we have this data, for example. No, sorry, from October 2020 till December 2020, we have this data. The last 3 months of data we already have. Now, with the help of uh, linear regression, we could just predict that, okay, so the January 21 data is 700 and February 21 data is 750. But this is not the most accurate way of predicting, because the sales could be very different in the real life. So we would rather make use of moving average. How does moving average work? The way moving average work is that the last 3 months of data, which was uh, 650, 700, and 560. We make an average of that, and we add all of them together, and we divide it by 3, and we say that 637 is the prediction via moving average for January 21. Then the next thing will be that we will uh, take the data of we will 700, 500, and 560, and then 637. We add these three together, and then we say that, right, so uh, and we divide them by 3. The average will be 653, and so on and so forth. So this is how we are going to predict the data of moving average via moving average. And the lines will be slightly different because it's not linear anymore. It's just that we are doing it slightly differently. So that's how we are going to do the calculations via moving average. Uh, moving average. Um, then there is something called click-through rate predictions. So suppose you have uh, a team which is tasked to run an ad campaign, a marketing campaign for a popular retailer, and you want to understand, you want to predict the probability of people clicking online on that ad, uh, and uh, and this is where this click-through rate prediction will come into picture. Uh, this is actually a facilitation data set which shows the click-through um, data rate of a few well-known um, uh, banks, something like HSBC and Lloyds and NatWest, where you want to understand that, okay, if these advertisers, I mean, if these banks, they want to advertise themselves in the leading publishers like Current Affairs. There's one called News Statements, the Statesman, and there's another one called The Week. So these are the three publishers. We have three banks called HSBC, Lloyds, and NatWest, and they want to understand that if they take, if they are, uh, you know, uh, uh, publicizing their their mortgage products, for example, their loan products in these three publishers. So in which publisher they will be most successful. So we see that on the current affairs website, while HSBC's is clicked 80 times, uh, in 100 clicks, 80 times the clicks goes for HSBC. But for Lloyd's, the clicks are 90 times, and for NatWest, the clicks are only 20 times. Um, so this means that we have if Lloyd's go on the current affair website, there's a better chance for their ad to be picked up from there as compared um, to NatWest and HSBC. And again, on news statements website, if HSBC, and NatWest go, there's hardly any chance for them, because there will be, out of 100 clicks, they don't have any click at all. But Lloyd's again have 85 click on their website. So and then on the week website, all the banks have got quite low clicks, but HSBC has got a better chance to have their advertisement picked up from the week as compared to the Lloyd's. So based on these prediction, they are going to decide that which the marketing teams of these banks are going to decide that which publisher will make them more successful, will make their um, uh, clicking campaign, um, the marketing campaign most successful. So it may be because the the readers of news statements, they don't have any accounts with HSBC and NatWest, but they do have quite a lot of bank accounts with Lloyd's, and they have done businesses with Lloyd's in the past. So that could be one of the factors because of which Lloyd is most successful with news statements, but HSBC and and uh, and NatWest are not. So this is how your click-through predictions work. This is a classification problem, as we discussed over here. The classification thing that all you have to do is to classify whether your ad campaign will be successful with a certain publisher or not. It's a yes or no answer, and the yes or no answer is dependent upon the number of clicks that the subscribers will be doing when they will be on a certain publisher's website, and yeah, so that's how it's going uh, to work, because you are only predicting the two outcomes, whether it's going to be a click or it's going to be a no click. Um, and now we have something called a decision tree problem. So you have to what you have to do over here is that uh, you want to understand um, whether a person he is going to whether a person is going to click on a certain ad or not, and that is going to and that is a prediction that you are going to make via a decision tree. So first of all, the question that you need to ask, this is the example of a sports company who are trying to to advertise their products on the general websites, the retail websites. So when they put their advertisement on the market, they want to understand that whether or not their website their link is going to be clicked or not, and this is something that they are trying to solve via a decision tree. So the first question that they are going to ask is that whether that person who is coming to the website, are they interested in these sports or they are not? That's the first question that they have to ask. So if the answer is no, then there will be no click. But if the answer is yes, then the next would be that if that person is going to be, is he less than 20 years or 20 years old or more than 20 years old? So if the answer is yes, that yes, the person is less than 20 years old, then there will be a click. That ad will be clicked. But if the answer is no, that person is not less than 20 years old, more than 20 years old, then the next question would be that which browser they are using. By the way, this is just a fictitious example, as you know. I mean, it's not a fact or something like that. It's just to understand that how decision trees are working to solve the click-through rate problem that we just discussed about the bank. Now we are discussing it from a sports retailer. So okay, so if the question, so if the person is less than 20 years old, then yes, there will be a click. If the person is more than 20 years old, then the next question would be that are they using um, which browser they are using? Are they using a Chrome browser or some other browser? If the answer is that yes, they are using a Chrome browser, then the next would be that which device that Chrome browser is on. Um, I mean, if the device is a mobile device, then uh, there will be a click. But if the answer is that no, it's not a mobile device, it's a laptop or a desktop, then there will be no click. And in the question that which browser they were using, if it was not a Chrome browser, if it was something else like a Firefox or an Internet Explorer, then there will be no click. So this is how the decision tree is going to work to understand, to predict the click-through rate for the algorithm. These are I mean, this is how the click-through algorithms predict based upon the decision tree. Now there is also something called content-based recommendations, and these recommendations are actually content-based recommendation is actually a part of real-time recommendation. So real-time recommendations have become a core component of businesses globally, and it is incredibly important these days for the businesses to understand their customers. Obviously, the recommendation engines uh, take that to a whole new level. Retailers like Amazon, uh, Netflix, Prime, eBay, Facebook, Apple Store, etc. They all use of machine learning techniques to recommend product to their customers. So two commonly real-time recommendation techniques are, one of them is called content-based recommendation. So here uh, some of the users, they previously purchased, uh, they have a history, they have a browsing history, they have a purchase history on that um, website, for example. So uh, their browsing history and their purchase history is analyzed, and based on that, recommendation of similar items are made to that customer that were brought previously by that user. So after crunching through the various features of that items, that technique generates a similarity score, and the product with the highest scores are recommended to the customer. So for example, in this example, this person, I mean, he purchased a pair of jeans. So the recommendation that will come to him will be similar pair of jeans in future, and not a pair of dress trouser, for example. I mean, if you are if you are a member of an e-commerce based website online, a retail store like uh, like Audible or Amazon or Netflix. You will get similar recommendation and regular recommendations based upon the choices that you have made in the past. Then there's something called user-based recommendation as opposed to the content-based recommendation. Now, in this example, again, a user history is a user's previous purchase history is analyzed. In this example, this person, user one, he is an athlete, and he recently brought a pizza and a salad. So the system wants to predict that what will be the next purchase of this person based upon what he has purchased very recently, that is a pizza and a salad. So that's the question. So what he's going to do is that in the user-based system, the technique analyzes what other similar users have been purchasing recently as well. So for example, that user 2, he is a cyclist, and he purchased a pizza and a salad just like user 1. He purchased a pizza and a salad, and then he also purchased a can of 7-Up, a drink. So now there's a third user as well, who is again an athlete, and that user has purchased a pizza and a salad, but a pastry and a loaf of bread as well. So now the system has got data of user 2 and user 3, because the things in common with user 1 of both these two, user 2 and user 3, is a pizza and a salad. So user 1 purchased pizza and salad, user 2 purchased pizza and salad, and user 3 purchased pizza and salad. But they also purchased some additional products like 7-Up, and this guy has purchased a loaf of bread and a pastry. So therefore, the system is probably going to make a recommendation to that person that the next thing he's going to purchase could be a can of 7-Up and a pastry and a loaf of bread, just because uh, the other two people with the same profile have purchased that. So this is a very simple example. The recommendation engines work at a far bigger scale and on the data, and you have applications like Netflix and Amazon Prime who make movie recommendations to you based on what you have watched and based on what others have watched in the same situation as yours. You have websites like um, YouTube, where recommendations are made to you with regards to watching the video clips that you have watched previously, and then you have Amazon and eBay, where the products are recommended to you based on what you purchased and what others have purchased in the same situation as you. So this is how the recommendation algorithms work. Now let's have a look at the conversational agents or the chatbots and see that that how they work for the businesses and how businesses make use of them. So now businesses are using this chatbot feature universally, and it has significantly reduced their operational cost uh, for most organizations, because they don't need the real people anymore, or to that extent to which they needed before. There are quite a lot of problems which are being resolved just by these chatbots or conversational agents. So the way is work is to the key is to design a chatbot chatbot for your business is to understand the intent of what the customer is saying through natural language processing techniques, which is called NLP. Now, it is quite a tricky task because even humans, they tend to misinterpret each other. They don't sometimes fully understand what the other human being is trying to say. And the when it comes to the chatbots or the conversational agents who are obviously not humans, then the problem could be even more severe. So machine, therefore, I mean, there's a level of difficulty for making machines to do that. The NLP system first analyzes the message from the customer. We have an NLP system which is called a machine, which analyzes the message from the system. That system could be in the form of a text or something like that. Uh, they try to understand the intent of that message. Then it crafts a reply in response to the customer and converts that into the text format. So the first thing is that they try to understand the intent. Based on that intent, they create a response. That response is converted into the text. That text is then sent back to the system where that I mean to the person where from where uh, the question came in the first place. So once this is done, um, the response is sent back. This is commonly used in the website these days, such as banking and energy sector and other service sectors, etc. We uh, business to customer companies, B2C companies, are relying upon on them more and more to resolve the customer queries, at least at a very basic level. Decision trees are used in these applications. The decision tree that we just discussed about for this uh, sports example, they are being used here quite a lot. So yeah, so this is the example of how the conversational agents or the chatbots they're helping the businesses these days. Uh, now then we have certain areas where natural language processing, which is called NLP, they are helping certain businesses. They are being very helpful in busting the fake news. So what happens is that for example, if a fake news is attributed to a certain person maybe or a certain event, that that certain person said gave a certain statement, maybe a political leader gave a certain statement, and they just put it on the website, and that website is propagated on the social media like Twitter and Facebook, and um, and something is wrongly attributed to that person who didn't even say that. So this natural language processing algorithm from medium to advanced level algorithms, they go around and they try to find out that whether certain person did actually said certain thing which is being attributed to him or not. They will take the data from different other news source. They will try to probably analyze the speech of that person. For example, I mean that person was in a seminar or in an event where this news is attributed to him. So these agents will go to other sources who covered that event, try to see that, um, try to analyze um, um, the speech and what that person said, and then they will say that probably what is being attributed to that person is fake because these NLP agents could not find such a thing being said by that person. And then, translating the languages. We all have Google translators and other translators on our mobile phone these days. It's quite, handy for the tourists these days to go in a different country. And for example, if somebody has gone to probably China, the Google, you have Google Translator on your phone, where you can from where you can get the translation of English into Chinese and Chinese into English. So this is being done. Summarizing the text, you have complete books like 400 and 500 pages of books. They are being summarized into maybe just 100 pages, to get the main gist of from that book by the virtue of natural language processing. Then analyzing sentiments and customer feedbacks. This is quite a useful tool which is being used by the companies to understand the value of their product in the eyes of their customer, whether their customers are liking their products or not. And it's very common, these days on Amazon and eBay and other retailers' website, where the customer can just give the number of stars, and they can give a thumbs up or a thumbs down, or and on social media, on Facebook and Twitter, the sentiments could be attributed to certain news and certain posts. And this is how the organizations would understand that whether their products, the news, what is the popularity of their products are there at the moment, based on the natural language processing. There's another use of artificial intelligence in the smart traffic light system, and the way it works is that wherever this smart traffic light system is implemented, the idea is to give the preference to the emergency vehicles like ambulances and fire brigade and police, so that they can reach to the point wherever they are needed without any obstruction. Even if there is a traffic, the traffic lights are red. If these vehicles, they are approaching, then the smart traffic light system is going to adjust the traffic light signal so that they can be given the priority. So how does this whole thing works? How do the smart traffic light system are going to recognize those vehicles? After all, a police vehicle could be a Ford car as well. An ambulance could be just a van, and a fire brigade could be just a massive truck. So how they are going to recognize that whether it's a police vehicle or an ambulance or a fire brigade truck and not the normal vehicles? So what they are making use of is something called convolution neural networks. So convolution neural networks is an algorithm which actually which is a deep learning technique. So an example in front of you is a dog. So a dog in this image, the CNN, which is convolution neural network, maps certain feature and divide the image of that dog into multiple parts. In our case, the model separate the body and the tail. You have this body of the dog and you have this tail of the dog. Then it takes each of the other part and analyze their salient features, which can be used to differentiate the object. For example, the eyes, the nose, the tongue, the paws. The CNN model picks up all these things, and then they just based on that information, they understand that whether the animal in front of them is a dog or not. They have millions and millions of images fed into them, uh, and then based on that, on those images, the system is going to recognize that, okay, so the object in front of it is not just an object, it's a dog, based on the quantity and the quality of the images which have been fed to them. The similar approach is used for recognizing the car, and for recognizing um, an ambulance, or a fire brigade truck, or a police vehicle. So what they do, I mean, this example, you have this BMW car, and there are millions and millions of samples um, which have been fed to the system of BMWs, their logos, their certain style, their the way their front looks, the way their back looks, and the windows and different features. They have been fed to the system, and based on this information, they will understand. The system is going to understand that the that the vehicle which is approaching, that is a BMW vehicle, because they already have this information in the form of the images which have been given to them. So this is exactly what the um, system does to the ambulances, and uh, to the uh, to the emergency services like police and fire brigade. Now, this is where I'm going to stop now. Conclude today's lecture. If you have any questions, then please feel free to ask. So I'm just going to stop the recording.